Welcome everyone. There have been some confusions among these boards in the comment section, as I could see. So I decided to talk about the ADS1256 boards again. And as you can see, now I have a pretty large collection of the different boards. So in numbers, this is actually 5. So I have 5 different boards, as you can see. Some of them are already attached to the STM32 microcontrollers, these two guys here. One has an embedded STM32 controller, and these two guys here are not connected to anything. So there were some confusions with the pins, so I want to clarify those because they have some different pin configuration which can be used to connect them to the microcontrollers. So I would like to clarify that. Before that, I just want to clarify also that this has an embedded microcontroller. Actually, this chip is identical to this one here. In fact, this microcontroller here is embedded in this board. So I showed some similar demonstration previously, but if I cover this part, then this board is basically this board here, and then if I cover this part, then this board is this STM32 board. So I hope that this is clear, and this works a bit differently because now if I have the STM32 connected to the ADS1256 in this kind of configuration, as you can see, then I have a USB connection. But in this case, I don't have any USB. This is this RS232. There is a serial connection and there is a JTAG connection here. This requires the ST-Link USB dongle. This requires an FTDI converter, and this requires an RS232 to serial or to USB adapter. So this is a bit different, but it's very easy to get an FTDI connector. If you see my previous video, then you can see that I use that to communicate with the computer through the USB port. So it's not a problem, but this is different from the other boards. So let's get rid of this because I don't want to involve this in this discussion. So we have these 4 boards. 2 of them have the STM32 connected to it. So it's this guy here. I just remove these jumpers. So nothing fancy, and you can disregard this. And we can also have an Arduino Nano if you like. So there is nothing different, because one thing which is common in these 4 or the other board as well, so in all of these ADS boards, that they use the SPI protocol, which means that whatever you do, you just have to find the SPI pins on the microcontrollers. And that means that either you have an STM32 or, for example, an Arduino Nano. You just have to look up the datasheet. So I put the drawing of the STM32 here, and then you have to look up the datasheet of the Arduino. So I put the datasheet of that part here, and you can see that these 2 devices have all of them SPI connections. Actually, this has more than 1. This has only 1, as far as I know. So you have to look up those 4 pins. And those 4 pins are the clock pin, the chip select pin, the master out slave in, and then master in slave out, or sometimes they say MOSI, MOSI, and MISO, which is MISO. So you have these 4 pins, and those are identical everywhere. So whenever you look up the back side or the front side of the chip or the PCB, you will see that it has a D in, it has an SCLK, it has a D out, and it also has a CS pin. And that can be found everywhere. So this guy here also, if we go from top to the bottom, CS, D out, D in, SCRK. Here, SCRK, D in, D out, CS. This guy also, SCRK, D in, D out, CS. So this is common. And then one thing is again common in these boards. They all have the data ready pin. So that's the DRDY. And the data ready will change its status. So it will go to high or to low depending on the status of the data. And as its name suggests, then whenever there is a data available on the AD converter, then the data ready will change its status or its level from high to low or low to high. I just don't remember right now. And that will tell the microcontroller that you can read the data now. So that's also common. So we have all boards contain that pin because that's an essential pin. Then let's check another pin. So we went through the SPI pins, they are identical. And then we found the data ready pin on all of these guys. That's also identical. And then there is a so-called reset. So what is the reset? So the reset is if you pull it down to low, then you do a hardware reset. You can force a hardware reset by that. So instead of using the code, which you can also do. So there is a SPI instruction which can trigger the ADS1256 to reset itself. So instead of using that, you use this hardware terminal, so this jumper wire, to reset the device. And that can be found on this board. It cannot be found on this board. So I'm showing you the picture that it is not on this ADS1256. So this is different, so I put it here. This guy has the reset, so this belongs to the same group. And this guy has it, RST. So these three have reset, hardware reset pins, but this guy here doesn't have. So what else can be found? So let's check this because this has the most pins. So again, I will repeat. So we found all the SPI pins, we found the reset pin, we found the data ready pin. What else can be there? So here I cannot see anything else. Of course, we have the digital pins. So here we have D0, D1, D2, D3. And then this is a bit confusing because it's mixed up with the input pins. But here, for example, it's here, the same. And then if we check, these are also here. And if we check, then this guy also has it. So you see the 4 pins, which are the digital pins. So that's fine. But what else can be found on these boards? So there is one more, sync. And sync is the same as the PDWN or power down or something like this. So we have the sync on this guy. And this has the PDWN, which is also the sync. So if you look up in the datasheet, you will see that there's this sync pin here. So there is this marking, this circle on the chip, and it's on the left bottom corner. So that's the sync. So we can find that. And this board has it. This board has it as well. So there we go, sync. So in this, it is sync. In this, it is PDWN. This guy Well, this is surprising because this doesn't have it. So what now we can see that this has a reset button or reset pin, but doesn't have the sync. And this has the sync, but doesn't have the reset pin. And then what this has is it has the reset, and it also has the sync or PDWN pin. So this is very nice that it has both of these pins. But what we usually do is we usually don't use the reset pin, and we usually don't use the sync or PDWN pins. So what I usually do in my circuits, so for example here is the sync in the rightmost corner in the bottom. That is this guy, and it goes to 3.3 volts. So if you follow the instructions of the datasheet, it says that if you don't want to use it, just pull it up to the high level, and then here I just use the 3.3 volts because that's perfectly enough. And that's all. So we don't have to care about that. And also, if you see this white wire, which is diagonal from that, so that is the reset, that is connected to another 3.3 volt. So that's what, because then again, the datasheet says that if you bring this down to low, the reset pin, then you force the reset. And also, you can do it if you don't want to mess around with the code, but I just don't feel the need of it. So it's connected to the high. And here, this just has the PDWN, and then here it goes to the corner, so it goes to the 3.3 volts again. So that's all. So if you find something confusing with these two pins, so sync or PDWN and reset, just connect them to the high or assign them to any of these pins, either on the STM32 or in the Arduino, and just write those pins. So you use the digital write, and then in the parentheses you write the number of the pin that you want to modify, and you pull it to the high level. So digital write something high, and then you get that pin at 5 volts. And if you connect the reset or the sync pin to that, then they will be at 5 volt, and they won't manipulate anything with your ADS1256. So this was one thing, and I want to go back to the board because this also tries to be something like a comparison. So when I go back to this integrated stuff, so what we can see that the size is not too different. I mean, I could squeeze this a bit closer. You see that there is a centimeter of gap here, but you see that this board doesn't take up too much extra space as compared to this combination of boards. And we still have the 3 pins. So those pins which are not used with this kind of connection between the AD converter and the microchip or microcontroller and the communication parts, those pins are here as these 2 set of jumper pins. Here we also have it, but maybe it's easier to access these things. So what I want to say is that it's much better to compact this thing down to this size, because if you consider that we have all these crazy connectors, then this might be a slightly larger stuff. So now, yeah, so I could fit there one more STM32, yes, that's correct. And this board still needs a small board, which is the FTDI converter, but on the other hand it has much more connections already prepared for you. So I think you don't sacrifice too much things if you use this. And yeah, this is better to use. And one thing, it's just an upcoming project. I did a sort of an introduction to strain gauges to measure very small displacements or deformations. So I printed a frame, you can see it here, and this guy on it has its own designated spot, and also this guy here has its own designated spot. So one project which can be done very nicely with this ADS1256 is measuring very small voltages and very small changes. So what you can see here is of course the STM32, the ADS1256, and this is for strain gauge amplifier. So these small things here, these four guys, those are the strain gauges, and they are connected to a Wheatstone bridge here, and then there is an op-amp, operational amplifier, and we have the 3 pins for the power supply, ground, and output voltage. And the output voltage is relatively low despite the fact that we have the amplifier here. And also, if we deform this small strain gauge, the changes in the voltages will be small. So that's not the main problem, that the output voltage of this thing is small, but the changes which are related to the changes in the deformation of this small strain gauge, those voltage changes are small. So then, since I have 4 devices here, I will use the ADS in differential mode, because then I have exactly 4 channels, and not because of that, but I have better signal to noise ratio with differential mode. So I will wire this up soon. I will connect everything. I will make some connections. Everything will be in a box. I don't know yet if I can fit it in a metallic box, then it will be in a metallic box. If I cannot, then I will put it in some plastic box, and then this will be a 4-channel strain gauge data logger or sort of stuff that can be used for measuring strain gauges. And I will write a small software for it to log the data and visualize it and so on and so on. But that's not a big deal. But why I'm talking about this is that this is one possible application where you can use the 24 bits of this device, where you can really use its power. So you want to measure relatively low voltages where you have relatively small changes. And then this combination is very nice stuff. I have a metal box here, so maybe I can see if it fits. Well, almost. So maybe I will try to fit in this box. I haven't actually decided yet, but we can see. But this is like really just some brainstorming. But maybe it fit. No, it doesn't fit. So sorry guys, it will be in a plastic box, but better luck next time. So yeah, this is one of the applications where you can use this very successfully, and hopefully I can demonstrate something to you. So I will sacrifice a few of these things. I have more, and I will attach it on a bar or some sort of flexible thing. Of course it will be a metal thing, and I will bend it or twist it, and we will see how this reacts to it. But I need to get some stuff to be able to glue this perfectly on the surface, because that's not that obvious task. So yeah, I hope I could clarify a few things regarding this or these 4 or 5 different AD converters. So they are the same, and I just want you to read a bit more from the datasheet, because one thing that you have to only understand is that all of these guys are using the SPI protocol. So you just have to find those 3 pins or 4 pins, sorry, which is the chip select, and data in, data out, and clock, or SCLK. So once you found those, you can send and receive commands, and then send and receive data as well. And then you don't really need to do anything else, because the only thing is that you have to read the DRDY pin. But then you have the reset, or depending on the board, you have the PDWN or sync pin, and you just have to connect them to high. And maybe when you cannot get any readings from this board, that can be one of your problems, that either you mess up the reset or the PDWN-sync pins, or both, and you don't tie them to the high, and then the board just keeps resetting itself. So be very careful and make sure that you connect the two mentioned pins to the high level, 3 volts or 5 volts. I would rather go to 3 volts because it's safer. I'm not sure if those pins are 5 volt compatible. You can check it in the datasheet again, but they should be 5 volt compatible, because this wall board is 5 volt compatible. So yeah, make sure that you connect them properly, and then you only have to take care of 5 pins. 4 for the SPI and 1 more for the DRDY. And obviously you want to power these devices, but it's very obvious everywhere that you have the 5 volt GND, or you have VCC GND, or you have DVDD and DGND, and here also GND and VIN. So yeah, it's very obvious. So I hope that I could clarify some kind of confusion, and you learned something from this. I strongly suggest you to check my other videos, for example, where I demonstrate this, or where I do some measurements with this device, and so on and so on. One of my first videos was based on this device, not this. I have another board of this version, which is used in another device. That was my very first project with this AD converter. So I strongly suggest you to check the whole playlist and binge watch those parts, because that can be very useful. And I show all the codings and stuff, all the bit banging or something like that for the SPI protocol, and so on and so on. So I hope that this was useful and instructive and you learned something. Don't forget to subscribe, so I will make some more videos about this, and see you in the next video.